Hello everyone, and then welcome to today's session. We are basically trying to revise for tomorrow's exam, paper 2 mathematics. So there's a question there on the board that says, AC is the diameter of circle ABC. Circle ABC, and then C2 is equal to C3. AC is perpendicular to FG. Oh, where are my glasses? It's perpendicular to FG, and then AD is parallel to FG, to CG, and then BC is equal to 6 units, and then the diameter is 10 units. It's quite an interesting question. Let's see what can we do with it. And then we need to prove that CAD is isosceles, or rather triangle CAD is an isosceles triangle. So properties of an isosceles triangle, as we know, I think, are that these two lines ought to be equal. So if we have to prove that ACD, or rather CAD, whichever way you want to put it, is isosceles, we can either say AC is equal to DC, or AD is equal to DC, or AD is equal to AC. We'll have to prove that. And also we have to find that this angle, it has to also be equal to that angle, or whichever way. So let's say solutions. Solution, it's fine. So now let's check, what is it that we are given? We are given that line AD is parallel to CG or GC. So if this line is parallel to that line, therefore this angle is equal to that angle. Let me write statement and reason. Where my markers? Black. Okay. Now, okay, so statement and reason. That is for number 1. So let's find out. We will say, therefore, angle A1 is equals to angle C2. Alternate angles. However, we were given that C2 is equal to C3, right? Given. Therefore, A1 equal to C2 equal to C3. It's fine. We can do that. It's measure trains measure. Nonetheless, I want to do something. I want to give this A1, C2, and C3. I want to put them, or rather to write them as X. Ne? I just want to do that such that I can solve these things easily. I prefer using X's. So I'll just say, therefore, they are equal to X. And then I can come here. If you remember, angles on a point, or rather angles on a straight line, they are equal to 180 degrees. They are supplementary. So I can say C1 plus C2 plus C3 equal to 180 degrees. We get angles on a straight line. And therefore, what is my C1? I'll write it as X. And then my C2, I'll also write it as X because they're equal. And then I'll be left with my C3, which is equal to 180 degrees. And then write C3 in terms of X. I'll write C3 is going to be 180 degrees minus 2X. Then I'll keep this thing. I'll write it as 1. I like to put notes on my questions, or rather my answers, such that I can go back to them, reasoning on what is it that I want to find. And now let's check triangle ADC or ACD. So in triangle ADC, we have A1 plus C1. Is it C3 though? We have C3 there. So this is not C3, it's C1. Sorry. It's supposed to be C1. I'm sorry about that. So A1 plus C1 plus D are equal to 180 degrees. Sum of angles in a triangle. Therefore, what is my A1? I said I should denote it as X, so sharp. And then what is my C1? I got it there at 1 as 180 degrees minus 2X, and then we have a D, which is equals to 180 degrees, all of them. So as you can see here, we have 180 here, and then 180 there. So I can just cancel them out, because if it goes outside, it's going to be minus. So, and then we have X and then minus 2X. I'll be left with minus X plus D equal to 180 degrees. Oh, I changed color. But it's fine. Let me continue with it. So not 180 is equal to 0. So I'll be saying, therefore, D equal to what? X. But let's check something quickly. What else is equal to X? We have denoted that in this triangle ADC, that A1 is equal to X there. So therefore, D is equals to X is equals to A1. So if D and A1 are equal here, that simply means CAD is an isosceles, because these are base angles of an isosceles triangle. Beautiful, right? Beautiful. Yeah, this is amazing. Now let's continue with question number 2. Where's that thing that I raised with again? Second question. Second question says to us, prove that BC over AC is equal to BG over AG. Where's BC? BC is this part that was given as 6 units. Let me just write it as 6. And then we have AC. Where's AC? AC is our diameter. We are given that diameter is 10 units. So this is 10. So now I want to do something. I want to find AB. If you can check something, look at line AC. AC is a diameter. Please, my diagram is not drawn to scale. So yeah. So AC as a diameter, that simply means this angle here is 90 degrees. And it being 90 degrees, it tells us because it was the angle that was subtended by the diameter, which becomes that 90 degrees. So therefore, if this is 90 degrees, we have ABC as a right angle triangle. So let me write every information down. Statement and reason. Now, we will say, since I don't know if maybe we have to write this thing, but I'm just writing it for you to understand it. Since AC is a diameter, therefore angle ABC equal to 90 degrees. Angle subtended subtended by a diameter. Sharp. Now again, we will therefore say, therefore triangle A, B, and C is a right angled triangle. Beautiful. Now we have set our conditions perfectly. We can use a theorem of Pythagoras to solve everything. So I can say AC squared equal to AB squared plus BC squared. What is my AC is 10 squared equal to what is my AB? That is the one that I'm looking for. AB squared plus 6 squared. I have 100. I'm just going to transpose exactly right now, and then I have AB squared. I'll have 64 equal to AB squared and then find the square root of both, and then I'll have 8 units for AB. Cool. But that's not what they wanted us to find, sorry. So now let me do this. I'm going to use both of these sides, né? Because I don't have enough space. I'll give reasons by saying them. So now I will say, if you can look at this triangle, it's upside down. So I'm going to say AB. Let me use a different color. Maybe this one will be perfect. I'm going to say AB all over BD, right? Or I did not state that also. I did not show. So let me just take you back in the previous question. We proved that CAD is an isosceles triangle, right? And if CAD is an isosceles triangle, and then we found that these angles are the ones that make it an isosceles, therefore AC is equal to DC. Since AC is 10, therefore DC is our 10. All right. I hope that makes. I'm sorry for forgetting to show you that. That makes that BD be 16. Cool. Now let's proceed and say, I said AB all over BD. Oh, sorry, AB on this side, and then this side I'm going to take BD, and then here I'm going to take what? GB, and then here also I'm going to take BC. So I'll therefore say, I'll be saying rather AB all over BG is equals to BD all over BC. So what is it that I have? What is my AB? I found it as 8 units. 8. Do I have BG? No, I'm looking for it. And then what is my BD? BD 16. Do I have BC? Yes, it was given there as 6 units. 6. And then I'm going to do cross multiplication. 6 and 8. Where's the calculator now? Oh, beautiful. 8 multiplied by 6 is 48. So I'm going to have 48 equal to 16 BG. And then 48 divided by 16 is going to give me 3. So my BG is going to be 3 units. So now, the question said to me, I need to say BC all over AC, all right? So which is BC all over AC. Cool. And then I also need to do BG all over AG. How can I find AG? Check AB is equal to AG plus BG, which is going to give me 3. This is 8 plus BC, and then BC is going to give me 5 units. Cool. Now, I'm going to say, where is that? BC over AC is going to be BG over AG. And then what is that? Where is BC? BC 6. And then what is AC? AC is 10. And then what is BG? BG is 3. What is AG? AG is 5. So if you can simplify 6 over 10, it's going to give you 3 all over 5, which is equals to 3 all over 5. Therefore, we have proven that BC over AC is equal to that. So we are done with that. We are done with that. Let's come here. Mathematics is a very beautiful subject. Oh, beautiful. Beautiful. I love it. Oops. Now let's find out. Let's find out before Pirates finds out. Okay, AFG. Where is AFG? Triangle AFG is similar to triangle ABC. Now there's something that we need to pay attention to. Let's statement. and reason. Cool. We find out that, let me say this is F1 and F2. So I'm going to say F1 is equal to B equal to 90 degrees. We have already gave a reason why B is equal to 90 degrees. It is because AC is a diameter, therefore it is an angle that is subtended by the diameter. Cool. And then what else can we do? What else can we find? AFG. And then A2 is a common angle. Is equals to A2 in another triangle. If you can say triangle ABC, right? We have A2 in triangle ABC. And again, in triangle AFG, we have A2, so it is common side. Cool. And therefore, if that thing is a common angle, this angle is equal to that, and that angle is equal to that angle. Therefore, we can therefore conclude that the other angle also has to be equal to the other angle. So meaning, in this triangle, we have this angle being equal to that angle, and then this angle being equal to that angle. Therefore, this one will be equal to that one. So we can say G1 is going to be equal to, I'll say ACB, common angle. Not common, sorry. Yeah, lack of better words. Let me say common. Therefore, triangle AFG is similar to triangle ABC. Reason is angle, angle, angle. Beautiful. Proceed. Let's proceed. Determine. Now we are up to finding values. AB. We've already found AB by theorem of Pythagoras. So let's find it anyway. So we'll say AB. No, this is not here. I'll be saying AC squared is going to be equal to AB squared plus BC squared. I'll be having 10 squared equal to, I'll be saying this is 4.1, right? Yes. AB squared plus 6 squared. 100 AB squared plus 36. And then AB squared is going to be 100 minus 36. And I'll have AB equal to squared 64. And then square root of both AB is going to be equal to 8 units. 4.2. Well, AG. Alright, we found AG also. Seems like we are working backwards, but it's not trying so much. AG. Alright, we had found that our GB is 3, right? So I'm going to say AB is going to be equal to GB plus AG. We already found that AB is 8 and then GB is 3, so we need AG. So we'll find that this is 5 equal to AG. So we are fine. 4.3. This shouldn't be much of a problem. Let's check for AF. So remember something. We are told that AC is a diameter. And if AC is a diameter, remember one thing, that a diameter is made by radii, meaning radius. So we'll be saying AF is basically equal to FC. If AF is equal to FC, that simply means we divide 10 by 2. So we will be basically having our F, or rather AF, being equal to 1 over 2 AC. Because AC is a diameter, so we'll be saying 1 over 210, which is going to give us 5 units. 5 units for AF. And that was that for this question. It is a beautiful question. We're done with this part. We're done with that part. Oh, this is beautiful, guys. Beautiful. And then make sure that you practice. Like, this is how basically you need to solve such questions. And then you need to make sure that you have basically the whole knowledge of your cycle geometry, Euclidean geometry, and make sure that you know how to amalgamate everything, and then you will be able to understand. And then if maybe it happens that the questions, you find them a bit tricky, relax, and then use different color pencils or other markers such that you can, on your structure, as you can see how beautiful I've basically marked my structure, you'll be able to see the diagram clearly, what theorem is there, and then what needs to be done, basically. So that's that. If maybe the questions would be, if maybe the examiner would have wanted us to do more questions, they would have maybe wanted us to find the value, or rather the length of AD. If you can check in this diagram, AD and GC are basically parallel. So if they are parallel, that simply means GC is half of AD, and then we can find both of them. We can find AD by theorem of Pythagoras, because we have 8 there, we have 16 here. We can find that, and then we find half of that to find GC. Like, it's beautiful stuff. We can, like, you guys, just do the perfect thing and practice. You won't go wrong. Trust me.